Hello! In this video, I'm going to show you how to get the greatest common factor or the GCF of two or more numbers using the prime factorization method. Of course, you need to review your prime factorization. Here, for example, we have 40 and 100. So first, we need to get the prime factors of both 40 and 100. So you can use any of the methods, factor tree or the continuous division method. So first, let us write here 40. Oh, my 4 is not good. Okay, so let us prime factorize 40 using the factor tree. So remember, if the number has 0, if the ones digit of the number is 0, his factor is 10 already. So we have 4, my goodness, my 4 times 10. Okay, here, 4 is not a prime number, it is composite number. So that means we can still get the prime factors of 4, so as 10. So what are the factors, prime factors of 4? So that would be 2 times 2, and then times, so we have 10, that would be 2 times 5. Okay, so here, all the factors now are prime numbers. So I have 2, 2, 2, and 5. So right here, 2. So we're not going to write the multiplication here, not just to save space, but of course, we know that these are factors. That means they are multiplication. Okay, next 100. Let's have 100 here. Of course, the easy one. Oh, I'm sorry. Let me just move it here. Okay, here. 100, of course, we have 10 times 10. Look at my 10. Okay, next 10 are 10 is not a prime number, so we can still get the prime factors of 10. So we have 2 times 5, and then we have times. So here 10, that would be 2 times 5 as well. Okay, now what we're going to do for the second number, 100 here, write 100. You align the common prime factors to the prime factors of 40. So for example, this one, 2. So this 2, you align it here, 2. Okay, next, 5. Align it to 5. And then the other 2, you align to the other 2 of 40. And then since 5, so there's no more 5 for 40, you just write it somewhere aligned to 100. And then those with common prime numbers, you bring them down. So here, sorry about the tail. So we have 2, then here, 2, and then it's 1, 5. Okay, and then multiply them. You don't need to bring down those with no partners. So the GCF, of course, oh my goodness, look at the writings. I'm just using mouse. I'm still practicing. So here, 2 times 2, that would be 4 times 5. So that would be 20. So the GCF of 40 and 100 is 20. Okay, so let us proceed to the next example. Here we have 12 15, and 18. So first, let us prime factorize those numbers. So first 12, then we have 15, then we have 18. Oh my goodness, my 8. Okay, so let us start with 12. So 12, find two factors using factor tree. You can also use the continuous division method here. So here 12, that would be 3 times 4, or you can use, of course, 2 times 6. Okay, so next 3 is already a prime number, but 4 is not. So you just bring 3 down and then prime factorize 4. That would be 2 times 2. Okay, so all of them now are prime numbers. So here write them line to 12. So 2, 2, and 3. Okay, next let us have 15. 15, we have 3 times 5. So 3 and 5 are already prime numbers. So align 3 here on the 3 of below the 3 of 12 and 5. So since there's no 5 here in the 12, you just write it somewhere aligned to 15. Okay, and then of course 18. Okay, so we have 18. Look at my 8. So 18, you can have uh, 2 times 9. Okay, 2 times 9. Okay, 2 is already a prime number. So you just bring it down. And then 9 is a composite number. So we can still prime factorize it. So the prime numbers are 3 times 3. There. Okay, so all of them now are prime numbers. So align to here, then the 3. So align the first 3 to the 3 of 12 and 15. There. And then there's no more 3 for 12 and 15. You just write 3 somewhere aligned horizontally to 18. And then bring down those numbers that is common, or that are common to the 3 numbers. In this case, there's only one common factor or prime factors. That would be 3. Okay, so that means the GCF of 12, 15, and 18 is 3. There. Okay, next, let's proceed to the third example. So we have here 9 and 16. So let us prime factorize 9, 16. So here we have 9. Oh my goodness, what's happening? Again. Oh no. Uh, uh, uh. What happened? Sorry about that. What happened? What happened? What happened? Still running here. The recording is still running. Sorry about that. So let's go back here. 9. So here 9. Oh man. And 16. Okay. So let us use prime factorization method. Sorry about what happened. I also don't know what happened. So 9 here, that would be 3 times 3. So write it here. 3 and 3. Then 16. 16. Oh man, the 6 can have 4 times 4. Okay, 4 is not a prime number. Can still prime factorize 4. So that would be 2 times 2 times, so 4, 2 times 2 as well. This time, all of them are prime numbers. They are all 2. So there's no 2 here as factors of 9. So you just write here 2 times 2 times 2. As you can see in this example, there's no common prime factors for both 9 and 16. If there's no common prime factors, the GCF would be 1. I just said it already. Okay, so the GCF is 1. Okay, here. And if the GCF of 2 or more numbers is 1, they are called relatively prime numbers. There. So they are relatively prime numbers. Alright? So I think that's it. I hope you learned something. If you have any questions, just comment down there the comment section. Okay? So that's it. I'm going to do the third uh, methods next time. So till then, bye bye. Bye bye.